Okay, we are back in chapter 7 again. This is 7.2. 7.1 was the law of sines, and 7.2 is the law of cosines. And we also use some of the formulas from the law of cosines to find the area of different size triangles, mainly oblique triangles. So here are your three formulas. And you can see for each one of these, the only thing that's changing is the placement of the variables. So the difference here in these three is this one uses angle A, the second one uses angle B, the last one uses angle C. So depending on what they're giving you in the problem determines what, which of the three formulas you would use, okay? So be careful when you're using these. Let me caution you real quick. The second half of the formula, the second half of each one of these formulas is 2 times the measure of 2 of the sides times the cosine of one of the angles. That whole amount is all multiplied together. So it's something squared plus something else squared minus this whole entire quantity. So the problem I usually see and the mistakes I usually see with this is people want to take this whole amount here and multiply all of this times the cosine of A. Well, that's not what the formula is showing. So make sure you put it in your calculator correctly. And if you're solving for either A, B, or C over here, you should be able to put this entire string of amounts in your calculator just like it shows A squared plus B squared minus 2AB cosine C. Whatever A is, whatever B is, use your multiplication signs there. And it should do your calculation for you, so you don't have to worry about, did I do it incorrectly or not? So be very careful with that. Make sure you are following the right order of operations. Okay, so again, we're going to use this to find different measures in the triangle. We may be given 3 sides and we need to determine what the angles are. We may be given 2 sides and an angle, and we need to find a different side or a different angle. So this is sometimes used in conjunction with the law of sines. So once we find a second angle or even one angle, then sometimes we can use the law of sines, which is a little bit simpler because we're not squaring everything to find the rest of the values in the triangle. So keep that in mind. Okay. All right, let's look at a problem. So here's our first problem. We know the 3 sides. So as I mentioned before, I'm going to draw a diagram. So it's a good idea to always draw a diagram. And again, so A is 8. That's our shortest side. We'll put that over here. B is 9. We'll put that over here. And C is 14. So we would have angle A, angle B, and angle C in that order. So make sure you remember the side that corresponds with the angle name A, B, or C is the side is opposite the angle, and the shortest side is opposite the smallest angle, and the largest side is opposite the largest angle. So keep that in mind. All right, so we need to find one of our angles, and we know that C is going to be the largest angle because it's opposite the largest side. So we're going to look for the largest angle first. So that means we're going to have C squared equals A squared plus B squared. If you guys haven't figured out by now, my lowercase a's I write as a capital, but I'm sure you guys can see that they're different. Times 2AB times the cosine of C. So we're going to plug in everything we know. So we know C is 14, so we got 14 squared. And A is 8, B is 9, minus 2 times 8 times 9 times the cosine of C. So if you're looking for an angle like we are in this case, you're going to have to use inverse cosine. And basically we need to get everything on one side of the equation. So I'm going to go ahead and square these. So if we square this, we get 196. And we've got 64 plus 81 minus We multiply all that together, we get 144 cosine of C. So we're going to start by subtracting both of these from both sides of the equation. Let's make that a different color. And if we do that, then that actually adds up to 145. So we're going to subtract 145 on this side. We're going to subtract 145 on this side. So we end up with, let's see, 51 equals negative 144 cosine C. Again, this value is multiplied by cosine. These two are added together, and then we subtract this whole value. So don't confuse, all the numbers are not being multiplied by cosine. All right, so if we divide, then we get that the cosine of C is equal to negative 51 over 144. And we're going to do the inverse cosine. So C is equal to cosine negative 1 of negative 51 over 144. And if we do that correctly, then we get 110.74. Okay. And again, on these, if the problem doesn't specifically tell you, then you would want to round to the nearest 2 decimal places, or nearest hundredth of a degree. All right, so we have angle C. Now that we have angle C, we could, instead of going through this long process, we could use the law of sines to find the other angles. So angle C, I'm going to highlight this down here, is 110.74. So if I go back to the law of sines, then I can say that A over sine of A is equal to C over the sine of C. Okay, and if we plug everything in, let's see, I get A is 8. So 8 over the sine of A is equal to C is 14 over the sine of 110.74. So let's draw some lines here just to separate this a little bit. So if we do like we would do with the sines, we're going to, again, remember, we're going to cross multiply. So we would multiply these two together, and then we would divide by 14. So we get the sine of A is equal to 0.534398. Now for that, it doesn't matter how many places you use. You probably want to use as many as possible so that you get the most accurate answer possible. And if we do the inverse sine here, then angle A is going to be 32.3 degrees. So we got angle A, we got angle C. Don't go through and do this whole problem again with either one of these for your third angle. Remember, all three angles have to add up to 180 degrees. So 180 minus 110.74 minus 32.3 is going to give us angle B, which is 36.96 degrees. So we got angles A, B, and C. We already had all the sides. We don't need to do anything with those. So we have solved our triangle. Okay. All right. Let's take a look at another one. So here they're giving us an angle and two sides. And again, I would suggest you draw your triangle. So we want to find the side that corresponds to the angle, because if we have an angle and a side that corresponds to each other, then we can use the law of sines. Okay. So you need to think about, when you see these problems, can you use the law of sines? No, we can't, because we don't have an angle that or a side, sorry, that corresponds with angle A. So we have to use the law of cosines to get that side. Then we can switch back to the law of sines. So the one we're going to use is A squared. It's nice when you're looking for a side, because A squared is equal to this whole quantity, and we can multiply it all together. So it's equal to B squared plus C squared minus 2BC sine of angle A. So if we plug in, well, I'll write it all out. So we got 3 squared plus 10 squared minus 2 times 3 times 10 sine of 55 degrees. So 9 plus 100, oops, minus 2 times 3 is 6 times 10 is 60, sine of 55 degrees. So again, if you put this in your calculator just like this, you should get your value. So if we do all of that, and remember this value here is one value. So let's actually go ahead and write that out. So we got 109 minus, and if you plug that all in, you're going to get 74.59. So a squared is equal to, I'm sorry, this is 34.41. And after we subtract it, we get 74.59. So at this point, you can do the square root of both sides. We only want the positive square root, so A is equal to 8.64. So remember, we're finding a side, so a side would not have a negative measure, which is why we're using the positive square root. All right, so there's A. So now we can find angle B and angle C. So if we use the sine of A over A, and that equals the sine of C over C, well, yeah, we'll use that. Notice I flipped these over. They're fractions. The inverse is still equal as long as you have the signs in the numerator or denominator and the matching sides of your triangle in the same place too. Okay, so the sine of 55, and no one caught me. I'm going to go back and fix all of this. Let's go back to the previous problem. The numbers are right. I just wrote sine instead of cosine. So this should have been cosine, cosine, and cosine. I was copying it from my notes as far as the numbers. The numbers are accurate, but it should be cosine. So now we're using the law of sines. So the sine of 55 over 8.64 is equal to the sine of C over 10. So basically, the sine of C is equal to 10 times the sine of 55. Again, you're going to cross multiply, divided by 8.64. And if we do that and take the inverse, then we find out that C is equal to, let's see, 108.84 degrees. And again, we have A, we have C, we can subtract. So up here at the top, 180 minus 55 minus 108.84 gives us 16.52, which is angle B. All right, so that's pretty much how we're going to be using the law of sines, okay? Now, we can also use, I'm sorry, did I say sine again? I said sine again. It's the law of cosines. So we can also use sine and cosine for area, okay? So let's take a look at these examples here. So here's an example where we have a triangle. We have angle A right here. The height of the triangle is B, and the hypotenuse, so again, this would form a right triangle. The hypotenuse would be C. So the area, the normal formula we know is 1/2 times base times height. Well, our height we can find is C times the sine of A, because again, the height or the sine of A is H over C if we call this H. So we can substitute that in for the height. So we get this formula. So if you're finding the area of any triangle and the two sides that you're given include the angle that's given, so notice here, side A and or side B and side C. Let's draw those. Let's get another color here so it shows up on our triangle. So side B there and side C form angle A. So A is included in between those two sides. So if that's the case, then we can use this formula, okay? And let's go ahead and do that because we have A, B, and C here. So we're just going to plug this in. So the area is equal to, let's say area. Oops, we're using K for area. Anybody, hopefully you realize we're using K because A is already the angle A. We don't want to mix them up. So K, our area, is equal to 1/2 times B times C times the sine of A. And you just plug all that in your calculator. It should go right in. Whoops, let's put in A there, 105. And that'll give us an area of 133. And we're not worried about units, but we'll say it's square units. So the number you're going to enter in WebAssign is just the 133. All right, so again, remember, that's when the angle is included between the two sides. If the angle is not included, so notice here it says we don't have matching information. Now I need my darker line. There we go. Okay, which means if you notice here on our triangle, I've got maybe 2 angles and a side. Well, I don't need 2 angles and a side. I need 2 sides with the included angle. So here's our formula from before. So I need to find angle or side C over here. Okay, that way I got A and B, or A in between B and C. So I can use the law of sines to do that. So we're going to use the law of sines, and once we have that, once we have the value of C, you can see right here we've kind of simplified that. Then we can plug it in to our formula and get it. So let's see how that's going to work. So I got 42 degrees, 76 degrees, and side C is 25. So I'm going to draw this triangle just so you can see what we're talking about here. So here is, we'll call this angle A. This is 42. That means this is A down here. Here's angle B. This is 76. And here's angle C. And we have side C, which is 25. And this is side B. So I either need A, and then I could use angle B, or I need B, and I could use angle A. So because I have the 25 over here, first off, I can find out what the measure of C is. So angle C, a little angle there so we know what it is 180 minus 42 minus 76, which is 62 degrees. So we can label angle C now. Angle C is 62 degrees. And now I can use angle C and side C, a little C over there, to find either A or B. Okay? I'm going to find B. So just because that way everything matches our formula and I don't have to rewrite it or anything. So B over the sine of B is equal to C over the sine of C. And if we plug everything in, we get B over the sine of 76 equals 25 over the sine of 62. And again, you could have gone back up here to this formula, which is basically what we're going to do now, except the B's and C's are switched. So B is equal to 25 sine 76 over sine 62. And if we simplify that out, B is 27.473. Okay, so I've got that. I've got angle A. Let's highlight that. I know what side B is now. I know what side C is. So I have an angle between 2 sides, or 2 sides with an included angle. So my area is going to be 1/2 times the first side times the second side, 27.473, times the sine of the angle. And if we work that out, we get 230 square units. Okay. And of course, we're rounding that off to a whole number. Again, read the question, pay attention to what they're asking you to do in the question. All right, the last thing we're going to do is a new formula. So this is called Heron's formula or Hero's formula, just depending on who you talk to and how they want to pronounce it. I've heard it's called Heron's formula, but anyway, it's basically a formula to find the area when you don't know any angles. So rather than, and again here, notice here's our three sides. It's not a right triangle, so we can't just do 1/2 base times height, and no angles are given. So rather than spend our time doing the law of cosines and then the law of sines or something to find angle measures, we can use Heron's formula, I call it Heron, to find the area of the triangle without even using an angle. So A, B, and C in this formula are the measures of sides A, B, and C. S is called the semi-perimeter. So we get that by adding all three together or finding the perimeter and dividing by 2. So let's find S first. So S is equal to 1/2 times 7 plus 15 plus 12. And if we work that all out, then we get 1/2 of 34, which is 17. So the area, K, is equal to the square root of S times S minus A times S minus B times S minus C. Make sure my 1 looks like a 1 there. 17. So plug everything in, and then you just need to simplify it. So we've got 17. I can't even write today, can I? 17 times 10 times 2 times 5. And if we work that all out, that ends up being 1700. And the square root of 1700 is approximately 41.23. So our area is 41.23. Again, we call that square units. I'm not going to be picky about the units, so you don't have to worry about that as far as I'm concerned. In WebAssign, you're only going to be filling in the number. If there are units, the units will already be part of the answer outside of the answer box. Okay, so that is section 2. I am going to be uploading this video for you guys to get started on that. And I am going to be probably doing a short survey with you guys about the final exam in the next few days. So look for an email about that. If you will reply to me, then thinking about a couple different things on the final exam, which might make it much easier for all of you guys. Okay, so there's section 2. Enjoy. Make sure you get your homework turned in on time. And as always, office hours, 10 to 12, Monday through Thursday.